Okay, so today we're going to talk about percent of increase and decrease. So just like we can find percent of a number, we could figure out by what percent did a number increase or decrease. Like for example, I think if I have if I'm up for a raise, I'm hoping I'm going to get a percent increase. And actually that's how they do figure out my raises. I think that's probably true when you're salaried. I get a 2% raise per year, or some years a 1% raise. There have been years where I've gotten a 0% raise, but that was a long time ago. Okay, so you would do a 2% increase, so you can figure out how much that would be. Or you have a percent decrease, like when you go to buy, I always go clothing or video game or whatever you're going to buy. If it's on sale or you have a 20% off coupon, you have a percent decrease of 20%. Okay, so we're going to look at how to figure out, solve those problems. Alrighty, so same TEK, here it is, but I highlighted the part of it we're going to work on today, involving percent increase and percent decrease problems. Okay, learning targets are pretty much the same. You're still going to have to write a proportion because we're still talking percent, so that's a proportional relationship. And then you're going to have to solve that proportion. Only now we're going to, and oops, I left a space in there, use a proportion to solve percent increase and decrease problems. So there's just like one extra little step we have to do. Okay. All right, so the percent of increase, so just like I said, since we can talk about the amount of something going up or down, either a lot of times it's tied to money because a lot of times it's a reduced price. I've seen a lot of problems like that, but it could be anything. We could talk about, for example, the infection rate, and like disclaimer, I didn't look anything up. I just made these numbers up. Maybe the infection rate increased 25%. So we can talk about how many more people now are diagnosed with whatever disease. Sometimes you'll see that statistic. They'll say, like the rate of diabetes is on the rise, and they'll give you a percent versus, instead of necessarily saying how many people have diabetes in the United States, they'll give you a percent, and then they'll look at the percent it increased, or hopefully, decreased. That would be awesome too. Okay, or like the cost of gas. I don't know if you all have noticed, but it's really come down the last couple weeks. It figures I don't need gas. I don't go anywhere, but whatever. So we could talk about the decrease in the gas price along with, well, it went down 5 cents. Well, what percent is that? Because that way, when you do things as a percent, you can kind of compare. Like, for example, percent kind of evens things out. I could talk about the cost of gas here is cheaper than like where I'm from in Pennsylvania. I'm assuming because we're close to Corpus where the refineries are. So we could talk about how much the gas costs, but it's not really, I can't really compare that because the base price is different. It's a good 20 cents more expensive in Pennsylvania. But if I talk about, well, our gas decreased or increased by this percent, and then, my grandmother in Pennsylvania talks about, well, our gas increased by this percent, now we can compare those because percent kind of evens everything out, so to speak. Okay. Okay, so again, if we have two or more ratios equivalent, there's proportional relationship. So we are going to, again, write proportions and solve for the missing value to get the answer for these problems. Okay, again, 3 ways. So we can use a ratio table with the scale factor, which is usually what I do. I think most of these problems, you can do it that way. You could use a unit rate, or you could just find the cross product and solve that equation. Okay, so let's do some examples. So a price of a television was reduced from $250 to $175. By what percentage was the price reduced? Okay, so since I'm looking for what percent was it reduced, I first should probably find out how much money it was reduced by. So if it was $250 and now it's $175, the price was reduced by $75. $75 reduction, so to speak. So we have to figure out what percent that represents. Okay, so I have $75. Let me start a little table here. Okay, so this is going to be my original, my 100%, my whole amount. Sorry, I wrote a couple of notes here for myself. So this is the whole amount. This would be what I start with, my original. Okay, and then this is going to be, my part is going to be my change, how much it changed. Okay, so there's a couple ways you can set this up. If you want to label everything, and I do like to label everything, this is where I'm going to put my money, and this is where I'm going to put my percent that represents that. So 100% of this TV, if I got no discount and I had to pay 100% of the price, I'd be paying $250. Okay. All right, so the change, though, was $75. And I need to know what percent that represents. Okay, so that's the way I'm going to set up that proportion. Okay, and then I'll show you another way to do this as well. I like to do it this way because since I'm talking about how much it's reduced, I first find out how much money or how many people it was reduced or increased by, and that's what I use for my part number. Okay, so for that number there. Okay, so let's see. That's the hard part, so to speak. Okay, once you have that down, the rest is it's just math. So let's look. I can't multiply, well, maybe you know what, you divide 250 by to get 100, but I can simplify this. So a lot of times I'll start by simplifying if I can, because that might get me closer. Okay, so I know 25 goes into 75 3 times, so I'm dividing, oh, I lost my pen, there we go, dividing by 25 to simplify this fraction. So 75 divided by 25 is 3, and let's see, 250 divided by 25, well, there are 4 25s and 100, so 8 in 200, and 2 in 50, so that's 10. Oh, and yeah, I guess I didn't need to go through all that. Okay, so that makes me happy because now I do know that to get 100 from 10, I multiply by 10. So in order to keep this proportion, keep these fractions equivalent, it's just like when you were doing, when would you do this? To find common denominators when you did fraction problems last year. So 3 times 10 is 30. So I know that this was reduced 30%. So it was a 30% reduction, or maybe I had a 30% sale, a 30% discount. All those things kind of mean the same thing. Okay? All right, so the other thing you could do with this problem is, I was just going to see if I can add, okay, let me add a page. Here, since here I am talking about reduced, how much it's reduced, that I figure that out first. And then that's where what I put in here, and then my answer is my answer. I don't have to do anything else with it. Okay? All right, so either way is fine. The questions, this question here, this price of a television is a released question, and they're all pretty straightforward like this. They're just different scenarios, but it's just it went from this price to this price. How much was it reduced? What percent? Okay? Keeping in mind that 9 times out of 10, if they're asking you like a discount problem, you're not going to save 70%. Okay, so if it's really high, go back and think, is that reasonable? It's not impossible. like we just had Easter, so you know they'll discount any leftover candy 50%, and if they still have some in a week or two, it will be 70%. So it's not unheard of, it's just not real common. So if you get a really high percent, go back and see what you did. Did you forget to subtract? I'm reducing it. I have to subtract somewhere. And like I said, I just think it's a lot easier to figure out the amount it was reduced and figure out that percent, because then I won't forget at the end. Okay? All right. And I'm going to just summarize my problem. We had $250 reduced to $175, and we need to find percent of decrease. So the other way you could do this is you could figure out, I got to think about this so I say it the right way. You could figure out what percent 175 is of 250. That means that's the percent you're paying, and then you can subtract in the end. So we could say, well, $175 compared to $250, what percent is that of 100, since this is 100%? X percent. Okay, so again, I like to label my proportion as I'm setting it up to make sure everything is in the right spot. So these here, this should be money, and then these should equal one another. 250 is 100%. Okay. All right. So again, we're going to solve this the same way. So as we did the other one, I'm going to start by simplifying. 25 will go into both of these too. 25 goes into 100 4 times, and then there's 3 in 75, so that's a total of 7. And this again is 25 times 10 is 250. Okay, so again, 10 times 10 is 100, and 7 times 10 is 70%. Okay, that is not how much it's decreased though. That's how much the 175 is. So if I've paid 175, that means I have saved 30%. Okay, now you can do it any way you want, and I know there are some teachers in 7th grade who do it this way all the time, but here's my thing. It is really, really easy to forget that subtraction at the end. Okay, so make your decision. I just think it's much. Let me see. The next example is a percent increase. So the math club increased its membership from 12 students to 20 students. Yay! By what percentage was the math club member increased? Okay, so again, I'm talking increased. So I'm going to go figure out how many students it increased. Okay, I had 12 students. Now I have 20 students. That means I increased 8 student increase. I increased my club by 8 students. Okay, that's a pretty big deal. But I want to figure out what percent that is, because that might not sound like a whole lot. Okay, so 8% increase, or 8 student increase, what percent is it? Okay, so let me get my table going here. This is going to be my change. Well, my change is 8. I have 8 more students. And this was what I started with. So original, starting, whole, whatever you want to call this. I started with 12 students, okay? 12 is 100% of my students. And then I increased it, okay? So 100% goes here, and I want to know what that is. All right, so if you want column labels here, this is the number of students, and this is the percent. Okay, so let me take my proportion there out of that little ratio table. 8/12 equals something out of 100. So let's see, 12 times what is 100? Well, nothing like easy, not an integer, it's a fractional number. Oh, but wait, I can simplify this. That might help. It might help, it might not. These are 7th grade problems, so I have not yet, now not that I've done millions of these, found a 7th grade problem that you couldn't do this way. I'm really hoping this works because I'm not sure at the moment. And you know what? Now that I'm looking at it, I don't think it's going to. But that's okay. And I think it's because I flipped this around. It was a percent decrease problem and I made it increase. So I messed with this problem. But on the test, if I would have left it alone as a decrease, it was decreased from 20 to 12. It may have worked. I'm not sure. So anyway, my point being, try this first, okay? Because 9 times out of 10, it will work. All right, so divide 8 by 4, I get 2. Divide 12 by 4, I get 3, and yeah. So you might know if you multiply 3 by 33 1/3, you will get 100, and that would be awesome if you want to do it that way. If not, then let me rewrite my problem so you can see what our problem is now. If not, then we can use the cross product, okay? Okay, so 2 times 100 is 200. That's going to be equal to this cross product. 3 times x is 3x. I get rid of my coefficient, multiplication by division. 3 divided by 3 gives me 1x. And then 200 rather, divided by 3 gives me, 3 goes into 20, let's see, 6 times. And then you have 6 left over. You bring down, or 2 left over rather, 18 minus 20 minus 18 is 2, bring down. Anyway, you're going to keep getting this. Okay, so we had a 2/3, it increased by 2/3. Okay, 2/3 is 66 and 2/3%. Okay, so 66, you could say 66.7%. You maybe might see this 67%, or my favorite way is just to say 66 and 2/3%. That's the most accurate. Okay, but you might see it rounded. Give me a second. I'm going to go check and see what the answer choices look like on the test, so I can let you know which way to do it. Hang on one moment. Okay. Yeah, that's right. I told you. I changed the problem. Originally, it was reduced from 20 to 12, which would put 20 as the original, which is the easy scale factor. Okay. All right. Sorry about that. Maybe I should redo this. No, I think we'll leave it like that, but let me show you the problem the problem from the test. And like I said, when I looked at this test, they're all percent decrease problems. That's kind of strange, I think. Okay, so the original question was the price was reduced from $20 to $12. And the question is, what is the percent? The question is, by what percentage was the price reduced? So what percentage was the price reduced? Okay, sorry about the writing, but that's why I'm talking while I'm writing, right? Okay, so again, I want to know reduced. Oh, jeez, so sorry. I thought I had the highlighter. There we go, reduced. So I first have to find out, in my opinion, the money reduced, okay? So the money was reduced. I'm saving how much money? $8. Okay, so if I'm saving $8, and I originally was going to pay $20, I want to know what percent that is from the original. So 100% of this sweater was $20. I'm saving $8. If I use this 12, that's going to tell me how much I'm paying for the sweater, which then you have to subtract from 100 to figure out how much you're saving. Okay, and like I said, I just think it's easier to subtract in the beginning. It makes a lot more sense to me personally, but you can do either way. Okay, all right, so here I don't have to even simplify because look, 20 times 5 is 100. So 8 times 5 is 40. So this sweater was reduced 40%. That's a pretty good sale. Now, as far as reasonableness goes, I'm just thinking if I have $20, if I reduced this, if I saved 50%, I would be paying $10. Okay, so I'm going to be, the percent is going to be close to 50% because 10 is really close to 12. So that you can kind of go through with multiple choice answers and kind of narrow it down, which one makes more sense. And I think you guys are really good at, well, half would be this. If I go half again, it would be 5. So, you know, like 75% would be $5, etc. Okay. All right. So let's see. Our next slide is back to our learning targets. Take a minute, think about this. Can you do this? Does this make sense? Especially this one. We want to be looking here. Okay. Do you understand how to use that proportion in a percent increase decrease problem? Okay, again, you're finding the percent of increase decrease, so your first step is to find the amount it increased or decreased. And that represents the part of your ratio. The whole is the 100%, so the whole is what you started with, before it was reduced or before it was increased. Okay, and then if all else fails, you can use that cross product to do it. Okay, all right, and there's credits, that's where I got the slides from, because you know I didn't design all those. Okay, so I think your next thing is that Mad Lib. It's going to have problems from today and yesterday on it. And just let me know if you have any questions.